Hi everyone, welcome to the video lesson for Thursday, March 11th and Friday, March 12th. It was a bit of a weird lesson since Thursday was a full day class but Fridays were half days. But we had the same general structure. We're reviewing mass to mass stoichiometry problems. On all classes we started with the warm-up, which looks a lot like your checkpoint. And if we had time, we tried to go over a little bit of that stoichiometry gizmo part 2. Now, the Stoichiometry Gizmo Part 2 was supposed to be due in class today. That was your asynchronous work for Tuesday and Wednesday of earlier this week. But I realized that was kind of a lot, so you do have until Monday or Tuesday next week to finish that. However, your first attempt for the stoichiometry checkpoint should also be in by Monday or Tuesday. It was released on Tuesday and Wednesday, but as of today, I've officially assigned you your stoichiometry checkpoint. Today's warm-up was another quiz warm-up, and it looks a lot like the questions in your stoichiometry checkpoint. I wanted to make sure you had a chance to try to answer one of these questions before you did so in the checkpoint itself. Warm-ups are graded for completion and not accuracy. I add up all of the grades of all of your warm-ups, and then I'm going to round up for your final warm-up score. So as long as you get a 0.6 or higher, you are definitely going to get credit for this warm-up. If you got less than a 0.6, then I highly suggest you resubmit it. You have infinite chances to resubmit this warm-up, so please continue to do so to make sure that you get your credit for doing this warm-up. In your checkpoint, you have 12 or 11 different options in the drop-down menus. So I want to go over with you how to best answer these so you don't get too lost in the reads. If you jump right into the checkpoint question, trying to decide what values to choose, you're going to get very lost very quick. So please do this in order, and I would probably write down your final answer on another sheet of paper or in another Google document before you actually find the answers in the pull-down menus. So it isn't so much that you're trying to find the right answer as you're trying to make sure that your box, your grid, looks like the grid that you made on another sheet of paper. Okay, so the question starts, if 22.5 grams of hydrogen, H2, reacts, how many grams of water, H2O, can be produced? The balanced equation is 2H2 plus 1O2 yields 2H2O. So the first thing we need to find is the molar mass of H2. So if I look on my periodic table, the molar mass of hydrogen is 1.01. Now, I have H2. So that means I have 2 atoms of hydrogen. So 1.01 times 2 gives me a total mass of 2.02. Next, I want to find the mole ratio from my balanced equation. Now, there's technically 2 answers to this one, but only one that Canvas will recognize as being correct. So to find my mole-to-mole ratio, I need to look at my coefficients in my balanced equation. So how many moles of H2 are equal to how many moles of H2O? Well, if I look at my equation, I have a 2 in front of my H2. So 2 moles of H2 are equal to, there's another 2 coefficient in front of my H2O. So 2 moles of H2 are equal to 2 moles of H2O. Now, if I was your math teacher, I would not be happy with this answer. Your math teacher would want you to simplify a ratio like 2 to 2. However, Canvas is not very smart. Computers, calculators are not very smart. Canvas will not accept 1 to 1 as the correct ratio. You need to use the ratio straight from the balanced equation. If you simplify it, you are technically correct, but the computer will mark you as wrong. If I catch that the computer misgraded you, I will give you back that point, but I might not be able to catch it in time. So please do it the way that the computer will grade you as correct, and you will have less issues. Then the last equivalency statement is looking for the molar mass of H2O. So I've already discovered that H2 has a mass of 2.02 because I've got the mass of hydrogen 1.01 twice, plus the mass of my oxygen. Now oxygen, if you round its molar mass to 2 decimal places, is 16.00. So 16.00 plus 2.02 gives me an overall molar mass of 18.02 grams per 1 mole. Now, an interesting thing you will notice is when you were selecting your answers for these equivalency statements, you had 2 or 3 different choices. I gave you quite a few wrong answers in each of these. I want to point out that for the molar mass of H2, the very, very wrong answer of 3.03 was there in the molar mass, but once you get down to these grids, there is no 3.3. So if you find your molar masses, you find your molar ratios, and then you go to fill in these boxes and the value you need isn't here, and there's nothing that looks similar to the value that you need, you might have made a mistake earlier on, and that's a really big hint that I'd really like you to use, that you need to go back and change your work. Now, before we actually start filling in these boxes, we have 11 values to choose from. Let's look at what values we actually need from this list. In your test, the answers do not get shuffled. They have the same 11 or 12 options in each of those green boxes that I've highlighted here, and has the same numbers in the same order. I give you your whole numbers that are used for those mole equivalencies, and then I give you all the molar masses and the given numerically. So you're not trying to find and identify the right number. You should know which number is the correct one and select it. So let's highlight the ones that we need. Oh, before I highlight the ones that I need, let's figure out what our given is. So if I read my equation, if I read my question, if 22.5 grams of hydrogen gas reacts, how many grams of water can be produced? So my given is 22.5 grams of hydrogen, H2. So let's look at our values. I know that I need 22.5. There it is, the second highest value. I know that I need 2.02 grams, so 2.02. I know that I'll need the number 1. Then I will need the number 2. I'll need to use that twice. And then 18.02. All those numbers that I didn't highlight are wrong numbers. They're never going to be used anywhere in this answer. Okay, so now we have our equivalency statements, and we know which values we're going to need. Now it's time to start filling out this grid. So the first thing that we always want to place in our very first box is our given. So I have 22.5 grams of hydrogen gas. So I take that 22.5 grams, carry it over here, and then I need grams of H2. Now it doesn't matter what's in my equivalency statements or my question. If I have grams of H2 in this box, I immediately know that grams of H2 is what I want to put into this box. Whatever is in here, I want to put on the bottom next grid. Now I need to look at my equivalencies. So grams of H2 is equal to moles of H2. So for my next unit, I'm going to choose moles of H2, and I'm going to put that unit on the top. So now I just need to find my values. I have 2.2 with grams and 1 with moles. Again, if I have moles of H2 here, I don't want to overthink this. I'm going to match that same unit on the bottom so they can cancel out. Now, I need to find the equivalency statement. Moles of H2 are equal to grams. I've already done that one. Now I have moles of H2 are equal to moles of H2O. So I'm going to put moles of H2O in the top. And then my value is 2 moles and 2 moles. Now I've got moles of H2O at the top. Once again, I want to cancel that out. So I'll get moles of H2O, put that on the bottom. And when I look at my equivalency statements, moles of H2 are equal to grams of H2O. And when I look at my equivalency statement, moles of H2O are equal to grams of H2O. So let me put grams of H2O on top. And then my values are 1 mole and 18.02 grams. Now let's double check our units. I have grams on the top in my numerator and grams in my denominator. They cancel. I have moles in my numerator and moles in my denominator. They cancel. Moles of H2O on top, moles of H2O on the bottom. They cancel. So I'm going to be left with grams of H2O. So now let me get my calculator. I'm going to multiply all these numbers on the top, and then one by one, I'm going to divide by the numbers on the bottom. So I have 22.5 times 1 times 2 times 18.02. Hit enter, and it gives me a number. That's a beautiful number, but I don't really care, because I'm going to take that number and I'm going to divide it by the first denominator, which is 2.02. Enter. Gives me another very nice number. Again, I don't care, because I'm going to take that number and divide it by my next denominator. Enter. And one more time, I have a 1 on the bottom. So my final answer is 200.72. 200.72 grams of H2O. Another thing I'd like to point out about this problem and the problems in your homework and the problems in your checkpoint, the order that I gave you your equivalency statements is the same order that you use them in your problem. So please use this as a guide to help you to answer your checkpoint questions. Next, I'd like to go over a few of the questions from your Gizmo Stoichiometry Part 2 homework. I took out that standard yellow show your work and answer box, and I replaced it with a question asking you to give the equivalency statements. And then I entered in boxes for you to set up your grid, because I wanted this to look just like your checkpoint. So in 1A, we've been asked, how many moles of silver, Ag, will be produced from the reaction between 0.15 moles of copper and excess silver nitrate? Show your work below. So my given is 0.15 moles of copper. My equivalency statement is asking for the molar ratio. So how many moles of copper are equal to how many moles of silver? Well, if I look at my equation, I have 1 Cu, and for moles of silver, I have 2 Ag. So let's start by filling in this grid with my given. So I have 0.15 mole of Cu. Because I have mole of Cu here, without thinking about my equivalency statement or my question, I want to get rid of moles of Cu. When I look at my equivalency statement, moles of Cu are equal to moles of Ag. So on top of mole of Cu, I'm going to put mole of Ag. So I have 2 moles of Ag is equal to 1 mole of Cu. Moles of copper in my numerator, moles of copper in my denominator means they will cancel out. Take out my calculator. And I have 0.15 times 2 divided by 1. So my answer is 0.30 mole of Ag. For this video lesson, I'm going to skip question 1b because it is exactly the same as this one. You're just using different coefficients. If I look to my problem, I can see that I have a coefficient of 1 in front of my CuNO32, and I have a coefficient of 2 in front of my AgNO3. Question 1c. I really like this one. It's different from the other ones we've done. It's harder than a mole-to-mole question, but it's actually easier than a mass-to-mass question because there's fewer steps. But we haven't done many mixed questions which have moles and mass. But we still work through this the same way. I start with my given, 3.50 grams of copper is my given. Then let's do my equivalency statements. I want the molar mass of copper. So when I look up copper on the periodic table, its molar mass is 63.55 grams. And then for my molar ratio, I just look at my balanced equation. There's a 1 in front of my copper, and there's a 2 in front of my silver. So let's set up my grid. I have 3.50 grams of copper. Because I start with grams of copper, I know I'm going to put grams of copper on the bottom. Grams of copper on the bottom, well, if I look at my equivalencies, grams of copper are equal to moles of copper. And for every 1 mole of copper, I have 63.55 grams of copper. Let me just change my color coding real quick. You know how much I love to color code things. Now again, I've got moles of copper on top. I've been asked for moles of silver, so I want to get rid of moles of copper. So to get rid of moles of copper, I'm going to put that on the bottom. And my moles of copper are equal to moles of silver. So moles of silver will go on top. So I have 2 moles of silver and 1 mole of copper. So now let me double check my units. Grams on top, grams on the bottom, cancel out. Moles of copper on top, moles of copper on the bottom, cancel out. So now I'm left with moles of silver. Let me take out my calculator. I have 3.50 times 1 times 2. I get an answer. Nice number, don't care. I want to divide that by 63.55, enter. And then I want to divide that by my next denominator, which is a 1. So my final answer is 0.11 mole of silver. Question 1D from our Gizmo was the last one we went over in class. The first question was, how many grams of copper 2 nitrate will be produced from the reaction of 1.80 grams of silver nitrate? So our first equivalency is asking what's the molar mass of silver 2 nitrate? Using the periodic table, I will find that the mass of silver is 107.87. The mass of nitrogen is 14.01. And the mass of my oxygen rounds to 2 decimal places as 16.00, but wait, I have 3 of them. So when I add this all together, I have 107.87 plus 14.01 plus 16 plus 16 plus 16 gives me a grand total of 169.88 grams. So 169.88 grams of silver nitrate is equal to 1 mole of silver nitrate. Next, I need my molar ratio. So if I look here, I've got a coefficient of 2 in front of my silver nitrate and a coefficient of 1 in front of my copper nitrate. Now, I just need to find my molar mass of copper nitrate. So I'm going to add together the masses. Copper has a mass of 63.55 grams. My nitrogen has a mass of 14.01, but there's a 2 outside that parentheses, so times 2. And then my oxygen has a mass of 16.00. I have 3 oxygens, but there's a 2 outside my parentheses, so that's a total of 6 oxygens. So add that all together. gives us 187.75 grams. 187.57 grams of copper nitrate. So now let's look at our question and to find our given. So my given here is 1.80 grams of silver nitrate. So in my first box, I have 1.80 grams of silver nitrate. So without looking anywhere else in the problem, I know that down here I'm going to have grams of silver nitrate. 169.88. If I have grams of silver nitrate on the bottom, let me go to my equivalency statements. According to my equivalency statement, 100 grams of silver nitrate is equal to moles of silver nitrate. So I'm going to put mole of AgNO3 on top. And if I look at the values, I have 1 mole and 100 and 169.88 grams on the bottom. Now, without looking anywhere, I can see I've got moles of AgNO3 up here, so I'm going to get rid of that by putting it on the bottom. Now, looking at my equivalency statements, moles of silver nitrate are equal to moles of copper nitrate. I have 1 mole of copper nitrate for every 2 moles of silver nitrate. Once again, if I have moles of copper nitrate on top, I know what I want to put on the bottom. I want to put moles of copper nitrate on the bottom. Looking at my equivalency statements, I have moles of copper nitrate equal to grams of copper nitrate. So grams of copper nitrate goes on top. I have 1 mole for every 187.57 grams. Now looking at my units, grams of silver nitrate, grams of silver nitrate, moles of silver nitrate, and moles of silver nitrate, moles of copper nitrate, and moles of copper nitrate. I'm being left with grams of copper nitrate, which is what I was asked for in the original question. So let me put this into my calculator. I have 1.80 times 1 times 1 times 187.57, enter. Then I'm going to divide all of that by my first denominator, which is 169.88, enter. Then I'm going to take that answer and divide it by my next denominator, which is a 2, enter. And then I'm going to divide that again by my next denominator, which is a 1, which will not change that final number. So I'm going to end with 0.99 grams of copper nitrate. Now the wonderful thing about this Gizmo worksheet is when you are done with each of these problems, you can see if the answer that you got is the correct one. Find the conversion factor tiles that match the conversion factors you put into your grid, Put them together, make sure that their units are correctly aligned, and see if you are able to get the same answer in the Gizmo as you did in your homework. It's a great way to check your work to make sure what you're doing is correct. Just make sure you're logging in with your login to make sure you don't get booted after 5 minutes. So that's all the time we had for in class, Thursday and Friday. I think we went a little bit further in this video lesson than we were able to get in most of the classes, but I hope this helps you guys out. Remember, if you'd like any extra practice problems, just ask me. I've got lots of worksheets and answer keys from years past. Make sure you try that checkpoint, at least get a first try in this weekend, and come and see me during office hours if you don't like your score, if you want to go over why you got that score and how you can do better. Until I see you guys next week, stay safe and make good choices.